Hello.
Hello, Terry. How you doing?
Yeah, good. Thanks. And you?
Can't complain. Doing all right. Just see if anyone else turns up in a few minutes. Hey.
Hello.
Hello.
Hi there.
So Ankit is on the call today. Ankit, I think you've met Terry. Have you met Michael?
No.
Okay. Ankit's one of our very involved community members who's doing great work on Zinc and Zex, and Michael Neal is one of our co-founders.
Oh, okay.
Nice to meet you.
Same.
Well, I guess we could. I guess we could start. I didn't really didn't have much to follow up from last week. I did spend some time fleshing out some more of the technical requirements, technology requirements in the roadmap. There was a few sections I sort of skipped, and I thought we could talk over them today. There was a lot of interesting stuff in the news on bias and AI algorithms in the meantime. I know we were talking a lot about it last week. So that was interesting. I put a few links in there in the notes for it because I know people are interested in that. There was one other thing I didn't put in there. Maybe I can. I'll find the article on reinforcement learning. So I know we've talked a bit about the different types of supervised, unsupervised, and reinforcement is sort of the three big, I guess, classes. There was an interesting article and paper from Facebook that I read on how they've replaced some of their supervised learning with reinforcement learning for things around push messages for groups and administrators of groups. So deciding when to notify people that there's something that might warrant their attention. They used to use a supervised trained algorithm that they would refresh every so often. But they explained why it wasn't optimal to do that because there was short-term stuff and long-term stuff and things you might be interested in later on. And they found that applying reinforcement learning actually helped them tune it better. But they do mention it had a downside of being even less explainable, which is something that Terry's brought up before, that, in theory, reinforcement learning ideally wouldn't be any different. You still should be able to go back to a point in time and explain how it got there. But Facebook being Facebook, it's not really their thing. So if I can find that article again, I'll add it. I'll add a link to the paper. I thought that was interesting. I've got it here. It was a link to sort of enterprise applications of reinforcement learning, which I hadn't really seen before. It's not that well known. It's usually more used in gaming or it might be used a bit in some of the self-driving stuff, at least sort of learning with simulators. But in sort of enterprise settings, you don't, if you're applying machine learning to some domain, you might not be able to simulate the environment. So reinforcement learning doesn't usually work, but that's that last link there. Thought that was an interesting read.
Yeah, and quite a lot of the problem that we're facing at the moment is that these types of learnings are very context dependent.
Mm-hmm.
So you can get the system to learn things, and those things will be useful so long as the context remains pretty much identical.
Mm.
But if the context shifts, there's currently no good mechanisms for machine learning systems to recognize context. And so you actually then end up with models breaking very quickly because of of a shifting context. So, for example, most models that learned things from people's behaviors pre-COVID are now completely broken because everybody's behaviors changed. And because there's no ability for the system to recognize a shifting context, it's very hard to manage that scenario, because you can throw everything away and start from scratch relearning, but then the context is going to switch back again, and then you've got the same problem in reverse, and you've lost your original model. So there's still quite a bit of work to be done in terms of enabling those types of learnings to go on within recognizable contexts, where the solution is learning the context as well as the patterns of behavior.
So does that mean you could have potentially multiple context specific models? Like you've trained a model previously, like if you could enumerate these contexts, I'm trying to think of an analogy. Like we've all, or probably all, you've gone to do a talk to a group of people, either customers or a community or whatever, and you kind of have to calibrate based on your audience, like what level am I talking at? And then you kind of swap in the context. Okay, I'm going to talk it this way, but that's not appropriate for all audiences. Like I imagine a similar solution for this, which does complicate things a bit. If you're going to have multiple potentially concurrent models deployed, you're not just replacing the old version with the new version, but you've got concurrent ones that switch in and out.
Yeah,
I could see that happening.
And certainly humans are incredibly context sensitive. And so you see behaviors where people will completely shift their behaviors in different contexts. So the way people behave in front of their parents compared to being with their mates down the pub will be a radically different set of behaviors.
Yeah.
But also you see situations where humans are able to do certain things very successfully in one context, and then are somehow unable to leverage that same behavior in a different context. So so the same patterns do exist within natural neural network systems, that that if you get the context flagging wrong, then you can learn something, but you can only do that thing in the context in which you originally learned it.
I've seen, I was just trying to look up then, I've seen ensemble neural networks where there's multiple networks or models, and there is also a neural network itself that decides which one to use. But I don't know how much has practically been used, but they sound like they've been a solution tried to, if you do have different contexts, then it's some learning is involved to even understand those. I mean, just the same as us. Like we learn when you're young, when you're a youth, you behave foolishly around all sorts of audiences, and you learn, okay, it's not okay to talk that way, at school or at home. That's completely normal to have different tones, and that's something we learned. It's not built in. So I think that's the intuition there. So there is, if you look up ensemble neural network, there's different articles on it, but I think they're viewed as very, very difficult to do, because it's hard enough to train one, but if you're training a bunch of them and then trying combinations of them, yeah, if you knew what those contexts were, then you could kind of partition your problem up. And like if you knew, like you're in wartime or peacetime or pandemic time, or outside of pandemic time, you could prepare. But I guess so that's kind of interesting. So yeah, I guess I'm trying to think of an analogy for software. Traditional software, when you would deploy it that way, you wouldn't normally have that many different versions of things running. Maybe, yeah, I can't think of an analogy in software of when you would,
Well,
you'd have a,
Feature flags.
well, I was thinking feature flags is one of them. You might go, okay, we're going to segment customers this way and this way. And yeah, sorry, Joe. Yeah, that's right.
You often have modal software packages where, you know, you're operating in a particular mode, and then you switch context and switch the mode of the package, and then it's doing a completely different function in that way. The art is in getting some level of metacognition into the machine learning models to recognize what context is actually valid, or to detect a changing context and therefore train a fresh model rather than
Harry, sorry, go on. I interrupted you.
No, I was just going to say, you know, that it would be useful to be able to have the system automatically fork a model and then start training different flavors of that in different contexts.
Yes, and did you not speak about this during office hours? I thought that you were doing some of these parallel trainings for even different aspects of a model and then combining sort of best in breed or best results.
Yeah, so we've certainly been looking at that and doing some of the ensemble stuff. So it's going to be helpful to be able to build things in that way. But again, there's this big shift between doing sort of structured and controlled training mechanisms that you can do within a CI/CD environment versus, you know, completely unstructured learning, which tends to happen at runtime in an unsupervised context. And it may be that what we need to do is look at ways of, rather than building an application that learns at runtime, you build an application that is reporting real-time metrics back to its own development environment, where the changes to the model are being reintegrated under the control of the CI/CD system and then redeployed in near real time, but in a more controlled fashion.
So this, you get the same end result, but you've got the pipeline in the loop there. So it's as if it was, you know, supervised training triggered by a person going, or a timer or whatever going, okay, it's time to retrain a model. It's happening. It's the same mechanism. It's just it's being triggered in a more continuous way. So I guess the pipeline in that case becomes part of the production, in a sense. Like it's just you got that the machine's always turning and it's always upgrading versus updating in place in runtime.
Yeah, and that gives you that more emergency control. You know, in the event that your system suddenly learns to swear, you can revert it back to a previous instance of the model with minimum disruption.
Yeah, I got it. Yep, I'll just take some notes. Yeah, no, that's, yeah.
I think this probably warrants a separate section in the challenges table.
The challenges or the requirements?
Well, we'll need to define what the challenge is first, and then
right. Yeah.
Find up from there.
I'll make a note of that.
And what metrics are you in general looking at, Terry? Because I mean, you can look at accuracy and loss, but this is rather different. This is more like a real world changes.
I guess it's the
Yeah,
real,
so,
it's the actual feature data, isn't it? Like the real users data.
yeah, so this is where it actually gets really interesting, because for those sort of self-learning models, you have to be very careful about what you give as metrics, because the system will seek to optimize the metrics that you've given it, whilst ignoring everything else. So it's it's very, very easy to get into situations where if you're doing positive or negative reinforcement, so if you're saying, you know, work towards this reward or work away from this punishment, the system will massively over optimize on that, often to the detriment of the task. Or it might decide to you know, opt out of the problem once and for all. So, you know, if it identifies the pattern of punishment as coming from a particular source, then it may refuse to do anything that involves engaging with that source, or it may try and remove the source.
Yeah, it's the machine version of humans taking painkillers to make pain go away and increase, you know, the pain, pleasure, pain, Freudian sort of thing. It's just finding a local maxima that suits a naive optimization.
Yeah, that's what I was thinking. I'm like, this is like the worst of human behavior.
Yeah.
You know,
It's,
relatable.
yeah,
Well,
because reinforcement is unsupervised. I guess it can do some of the job of supervised, like you give it goals and rewards to try and optimize something, but you're not. Whereas with supervised, I guess you're explicitly telling or giving, you know, say rows of data or records or some data that's labeled saying this is this category, or this is good, this is bad, this has this score or this score, or there's some judgment that goes along with the example, and then it kind of fits its view of the world to match that. Whereas reinforcement, you're sort of saying, I would like this value to be as low as possible, and here's the environment you can play in. Maybe there's a simulator, maybe there's not. That sort of that last link in the agenda thing is an interesting write-up on it. I found it interesting, but it's the idea is to achieve the same sort of thing. It's just it might have unpredictable results because you told it to optimize something. So like I've seen there's a company that does this to optimize settings for auto scale or JVM flags, you know, things as mundane as that, using reinforcement learning, and they run it in a staging environment while your application's running under a integration test workload. But a naive version of that, if done wrong, it might, you know, you might think, okay, I'm going to tell it to use as little memory as possible, and so it decides, well, I just won't run your app. So I've answered your problem. I guess there are a bunch of changes that's probably an obvious one, but you could have it come up with something unfortunate, or the swearing problem. I think I like to call this the swearing problem that Terry coined, like that Tay Microsoft bot, is definitely one of the technology challenges for this kind of learning, which is emerging now.
Yeah, and this is obviously you see this in a business environment, you know, where if you give teams a set of KPIs, they will optimize for those KPIs and neglect everything else, except that they typically operate within some sort of overarching moral framework. So they're self-regulating against that framework. But you know, our machine learning systems don't have the 3 laws of robotics to guide them. So you know,
there's no common sense. There's no, yeah. It's still an emerging field here, and Yeah, I'm wondering if, I don't know, Terry, if you know anything about transfer learning. I've heard that mentioned a few times where you have sort of pre-trained models with some basis of knowledge, and then anything you do, you add on top. Maybe that could be done by having some sort of hardwired data in there. I don't know, but have you come across that in your travels?
I haven't experimented with it myself, but I think there will be some interesting opportunities in that area.
Yeah, because that might be a solution to a lot of these things, is to have sort of pre-trained common sense, if you will, for given environments or contexts. But yeah.
A lot of the off-the-shelf models being provided by cloud providers and such like are pre-trained, you know, and then you take them and you either apply them directly or you do some amount of transfer learning.
I've seen there's sort of a marketplace. Like, I'm only really familiar with Google. I think SageMaker has some too, but there are a bunch of sort of vertical ones. And then there's a bunch of sort of, like, I've been using some natural language stuff from Google, which seems to work pretty well, but I actually don't know how it works. They don't really, they'll sort of tell you how it breaks apart syntax and does certain things, but there's no underlying explanation, which is, you know, not great. But no, I don't know if people do that yet. Like, but there certainly is a marketplace for things. You can sort of find one that, you know, will categorize certain things a certain way. And from what I've seen is that they come with, you know, the training data, the scripts, and the notebooks and everything, and then you can try it out and adapt it, and then you kind of change the data a bit, bring your own data. I haven't really seen sort of binary models that you bring along and then transfer your stuff into it. But Amazon claim they do that with their Cognito. Is it Cognito? One of their natural language APIs has, or maybe it's Google, has an understanding of, you know, n different languages, but you can also bring along your own set of training data in, you know, either a tabular format or whatever that's categorized or ranked in some way, and then it will learn from that, and it says it transfers that on top of the existing model they've got. So I guess there is commercial examples of it out there, but like, I haven't seen, like, here's one for working with, you know, automobile insurance, and it's got all the common sense in there. It's not going to do anything stupid. I haven't seen any sort of marketplace for that yet.
I mean, the reality is that for most commercial applications of machine learning at the moment, you have a central model which is detecting certain features, and then following on from that detection, then you've got a bunch of conventional programming to try and catch and block all of the bad decisions that you're also getting out of the model. So it's a general case plus a bunch of hard-coded exceptions to manage real-world scenarios. And actually, that's probably something that we should touch on in the roadmap as well, because that will be a very common pattern, is the need to be able to deploy a model, but then wrap that model in a bunch of sanity checking and sort of emergency cutouts. So it's probably worth us flagging that out.
Is that a challenge or a technology? I guess that's a technology requirement to have a.
Well, again, the way we structure the document is we specify the basic challenge. This is the thing that you need to be able to do, and then we expand on what that would mean from a technology perspective in terms of, you know, being able to easily wrap a service in another service, and you know, then you could go on to talk about some of, you know, available routes for doing that today, or what we might want to design and build in the future to make that simpler.
Well, I'll take a note, and when I look at the document, I'll try and add those two challenges. One is the swearing problem, and one would be some sort of emergency cutout. They're probably related. It might be the one thing, but I'll have a go at adding that to the challenges sort of section in the coming week. So I guess, do you want to open up the document on your screen, Terry, and we can. I had a few
sure.
questions on the technology requirements section. So if we go down to the first TBD, so that one there says providing mechanisms by which changes to training sets, training scripts, and service wrappers may all be auditable across their full life cycle. Very closely related to versioned appropriately. Like what I'm having trouble sort of understanding what auditing means in this context. Like I often think of auditing is like, well, if there's a clear record in something like signed git commits, then that's pretty good for a lot of legal requirements and that. Like what are you thinking here?
So let's look back at what the original challenge was that goes with this. So that was that one. So so this shows you some of the scenarios that we need to manage. And in fact, it looks as though we touched on the self-learning in this area.
It's a bit blurry, your screen, so I'm not sure which one. Can you read out the left-hand column paragraph of the challenge?
Okay, so let me just see if I can share that instead. Hang on.
Or maybe lower the resolution. Is it just me it's blurry for? Could be.
It's because it's doing video compression on
On text.
Yeah.
Yeah.
Let's see. I think it's that one.
That would explain it if that was the case. Oh yeah. Yeah, that explains it. Oh, there you go. Didn't know that. Yeah, that's much better. Thank you.
So what we really need to expand on in the technology requirements is what steps you would typically need in a process to allow you to do a root cause analysis or to support a legal investigation into an incident.
Mm-hmm.
And I would also expect that we'll see a move towards legislation that says that third parties are required to audit sensitive decision-making systems. So you may see that some of the large sort of accounting audit companies moving into providing ethics or bias audits on decision-making systems for their customers in the future.
So that, to me, that looks like it touches on the legal stuff, compliance, and possibly explainability. Would explainability be a requirement? I guess we don't know.
So in this particular instance, what we're looking at is how we would create an audit trail of changes across the system. So so this is where you actually need to have a chain of records, because you may be adding new training data to your training set, which has then triggered you to run a new training, which then gets you a new model, which you then deploy, and then something happens, and you need to be able to work backwards from something happened to what actually changed. And so the root cause would have been the new training data that was introduced. So you would want to be able to tell exactly what the difference was in the training data for that particular incident.
Right. So the auditability. Are there any? I know things like Sarbanes-Oxley triggered sort of a push towards configuration management, 10, 12 years ago, being sort of standard across an enterprise. Are there any sort of existing, compliance laws or practices that, should be mentioned here? I guess this is the technology one, so not really. Like if it was Sarbanes-Oxley, you wouldn't mention it here. So yeah, that doesn't really matter. No.
Yeah, I mean, I think there's very little formal legislation at the moment, but there's a lot of stuff in discussion. There are a number of groups pressing for sort of ethics analysis and bias detection. There are obviously a number of lobby groups arguing that we shouldn't be using machine learning to displace people out of jobs. So, we can expect to see a lot of new legislation over the next few years. Much of it quite knee-jerk in reaction. So I would fully expect that the compliance load on organizations will go up very steeply when it comes to managing anything associated with machine learning. And therefore there will be a long-term need for mature tooling that helps you to manage the end-to-end problems.
So the next row after that, the treating training sets as managed assets under MLOps workflow. Is that sufficiently different from like two ones above? It says providing mechanisms by which training sets, training scripts, and service wrappers may all be versioned. Like, what's the difference between treating it as what's a managed asset? I guess I'm asking. Is this kind of a big data problem? Like training sets could be, gigantic. Yeah.
Well, I think the difference here is that one thing is about being able to track an end-to-end view of change, whereas the other is actually about being able to identify differences in the first place. So the big challenges in that space sit in the data space.
Right. In the second case, it's about right. So a managed asset would be. So say you've got a change in your training set, and like if it's source code, you do a diff. If it's data, you don't really do a diff unless it's a trivial change, but you might, there's some statistical report, like what's the, portion of data in these category versus that. How does that differ to the old one? Like, is that what you mean by a managed asset? Like you?
Well, no, it's more like if you've got a set of compiled source code, that is an immutable asset at a fixed version. So if you've got version 1.1 of the of a compiled application, then you can obviously check the you can put checksums on the set of bytes that you've got in the data to validate that what you've got is an identical copy of a fixed asset that was
Right.
produced by an organization. So
Yep.
there you have a situation where you can guarantee that what is being used is an explicit snapshot of a particular asset. But
Hmm.
in the data space, people are much more used to using mutable data sets. So in many cases, they're just running a training on a point in time on a mutable set of operational data, and that point in time may have been, a given millisecond, and you're actually unable to identify what data was even in the training because it changed a few seconds later, and nobody kept any record of what it was
Right.
when it was used to do the training.
Right. So the requirement is to do with sort of reproducibility and like yeah, the checksum idea. Like you didn't. Yeah. Okay, that makes sense. And later on, a solution might be, well, if you're extracting data to learn from a mutable source, then you're going to need to keep a copy of it. If the underlying, you might be using a relational database that's not using a ledger or anything like that to keep a track of all changes, in which case, the solution in that case is you're just going to have a copy of that data somehow. That's kind of the implied requirement there.
Yeah. And that actually
or
takes
the
you
solution rather. Yeah.
Takes you to a different place in terms of the way in which you want to structure your data management capabilities.
Yeah.
So that's much more looking towards tools that can actually do fast, lightweight snapshots of data.
Yep.
And then manage
copy on write things, deltas, or whatever it is. Yeah. Yeah. There's lots of solutions for different sizes of data. Yeah. Okay, that helps. So moving on to the next one, section, the managing the security of data in the MLOps process, with particular focus on the increased risk association with aggregated data sets used for training or batch processing. So like an obvious example of that would be personally identifying information, or confidential. I think we've talked about this before. Confidential information or information that someone has a claim to. Is that right? Like that's so security from the point of view of exposing data. I guess is that what it means? Like you need to have access to this data to train a model, but the raw data is riskier to expose. Like it might be less risky to have the model go out there, just like people are more sensitive about source code in a proprietary world than they are about the binary for obvious reasons. Like this is kind of the analogy there. Is that, or is there more to this than that?
This is one that I've actually asked the Kubeflow guys to write some pieces on, because obviously they've had a recent experience with this, and it'd be useful to get their input on this particular area. I mean, the example that they had was actually on Microsoft's cloud, where what they'd done is given an option to people saying, tick this box if you want to expose a dashboard for the system, but if you're going to do that, you're going to have to manually install a bunch of security systems around it. And of course, what happened was everybody ticked the box and nobody did the manual work to put the security around it. And as a result, people were then using that as a vector to take over people's CI/CD environments and use them for mining cryptocurrency. So, it's often a case that there's a trade-off between convenience and security, and you actually have to potentially set the convenience barrier differently for systems that are going to be used on, target-rich environments. So, we probably need to expand on this section to flag the fact that machine learning applications are typically going to be in more challenging areas of the customer's business and generally higher risk, and therefore
they're also going to require a lot more data, and a lot more data means a lot more exposure. Like they're not like a microservice that's stateless that will just get pushed the data, makes its, does its calculation, for some interest rate or some brokerage fee or something, and the amount of data that you sort of collect and massage and extract and maybe store, because you need to keep it stored somewhere for training a model is so much bigger than that. So having the data exposed itself is a risk that you might not have.
And
you're just going to have more copies.
The other side to this is that typically the reputational damage associated with a breach in this area is going to be much higher.
Yeah.
Because it's going to be a breach associated with a lot of personal data or sensitive information. Yeah,
it's not just people cracking in and running crypto miners. Data can be exposed and sold. So one thing someone asked me about, so I was looking at training from issue trackers and things like Jira, sort of data in that semi-structured format, some of which is text, like the names of things, but then there's other categories and priorities and project names and labels and all this other stuff, and people going, well, could you obfuscate that data before, as you extract it out of the sort of the original system, as you extract it and prepare it for a training run, could you obfuscate it as part of that, like with a sort of one-way hash? Because the model doesn't really care that the project's called Project X. It could just be some arbitrary value as long as it can map. I guess that sort of begs the question of maybe that sort of hashing is not really cryptographically secure, so it's a bit of security theater. But I thought that was an interesting point someone brought up. I don't know if people actually do that. Obviously, if it's numeric, then you have to kind of keep it. You need to preserve the scale. You can't hide numeric. If it's plain text, you want to do NLP on. Yeah.
Well, typically, in order to do your processing in the first place, you're actually having to encode all of your data into a numeric form so it can just do maths on it. So, yes, there's a series of steps that you would do to redact certain information out of your training sets and then to encode that information. But this actually throws up another problem, which is that same process then also has to happen operationally in order to be able to use the model. So all the processes that you apply during training also need to be transferred over with the model and implemented as part of the operational system. And we have got another challenge in the table that we need to address, which discusses that problem. But yeah, there are issues in that just substituting a number for a a name is often insufficient
Hmm.
to generate real privacy.
Yeah, it's not.
If you-
Yeah, there's lots of science on that to show how things could be. Because fundamentally, it does map to something in the real world, because you have to do that when you do a prediction or feed something to the model. It's kind of a one-way thing. I guess it's at most, maybe it's a defense in depth thing where it's a little bit more opaque. But having said that, if you so say some of the previous problems is you need to be able to prove how your model was trained, then you need to be able to point back to the original source data in its unencoded form, in the case of an audit, to go like, here's the set of, insurance claims that we fed it on July 2019. You can't give just the encoded form for that, because you can't, it's, most of these things would be one way. You can't necessarily go backwards. Like if the original data is gone because it's immutable store, then you would effectively be unauditable. Like you wouldn't be able to show. So I guess, yeah, I can't remember what I was saying, but I guess you kind of, it doesn't really completely help. There's no way to just totally obfuscate it, just by design.
Well, also you've got situations where there will be pieces of information that are rare enough that they will be identifiable if you have a certain number of them. So if you know roughly where somebody is, at a county level, and you know that they have a certain medical condition or some other rare distinguishing feature, you're only going to get 2 or 3 hits of that combination in that area. So you're already nearly into the data set. And in many cases, what you can do is adversarial attacks on the model, where you're putting data in which you expect to trigger against certain scenarios, and therefore you can actually detect whether someone is in a model by manipulating the inputs that you put into it.
Well, I think there's some meat to chew on there, and after those, there's about 6 or 7 more to go. Some of those other ones are more technical, but I think we might call it a day today. I've just gone past the 45-minute thing. So yeah, I guess, is there anything else anyone wanted to throw in at the end? I think there's stuff that we can go away and chew on. I know I've got some action items to add some challenges and flesh out some things. But there was nothing to follow up from last week. Was there anything else?
No, I think we had several contributions that we've merged back in.
Yeah, I saw that. That was good. And I'll just take a note of attendees for the minutes. And yeah, well, thanks everyone for hanging out.
Yeah,
always interesting conversations. And see you next time.
Bye for now.
Bye.
Bye.
Thanks, guys. See ya.